A professor showed me a shortcut to solving integrals right here using the limit definition and Riemann sums. And I no longer feel the need to crash out in the library when I'm trying to solve these problems, so I'm going to share that with you here now. The first thing you're going to want to do is, I have my formulas for delta x and xi up here. So we're going to start with delta x, and that is b minus a, right? And this is the integral we're solving, so we got b minus a, 4 minus 2. 4 minus 2 over n equals 2 over n, right? So now we have xi, which is going to be a plus delta x times I, right? So here we just have a, and our a is 2. So 2 plus, and this is our delta x, plus 2 over n times I, which just equals 2 plus 2i over n. The next step is to put xi into f of x. And what that really means is just anywhere you see an x, we're going to replace it with this. Okay, so I've now put xi into f of x. And a pro tip right here is, you can see the formula includes this limit, but the second you write limit, you have to write it over and over and over. So we're just not going to write that until we need it. So right now we just have this times delta x. This delta x is right here, 2n. A big mistake I did when I was first trying to learn these is that I'd always forget the delta x, and I get like close to the right answer, but not quite. The first thing here is, you would think maybe distribute the 3, but no, you have the 2 here, and you need to solve that first. The difference is, or the formula for this is, you're going to square this one, times these together, and then double it, and then square this one. You could FOIL it out and do this, like a, b, and do it that way. That way it works, this way it's just faster. I'm going to move down over here. Okay, so what we have is 2 squared, you have 4, easy. 2 times 2i over n is going to be 4i over n, but there's 2 of those, so that's going to be 8i over n. And then this squared is just, you square everything there. The next step here is you want to distribute everything. I'm going to start here with the 3. And it's just going in like that, right?
Now so I'm going to have 12 plus 24i over n plus another 12i squared over n squared.
And then we got to put this in here. I will move down. Now you can see that we have everything distributed, and something just to be careful of when you're first doing these problems is, this was an n and this is an n squared, right? But since there's an n on the bottom, first of all, the 24 gains an n, but this becomes n squared here and n cubed here. That's just another little thing you can mix. The next thing we're going to want to do is split up all these summations. And anything that does not have an I can actually get pulled out in front of the summation. And that's kind of part of the shortcut. I'll just do that here real quick. Now, the next, you can see here I've split it all up, and everything that does not have an I gets pulled out. So the only thing that's part of the summation is I here and I squared here. And right here there's just a 1 because when you pull everything out, you have to leave something. It's a 1. The next step is to plug in the summation formulas. For 1, it's just going to become n. For I, it's going to become n bracket n plus 1 all over 2. And then for I squared, it's going to be n bracket n plus 1, new bracket 2n plus 1, all over 6. So I'll just write those all down. Okay, so now is time for the shortcut. I've replaced all of the summations with the proper formulas. So what we're gonna do now is we're gonna take the limit. And as I'm sure you learned in Calculus 1, when you're taking the limit to the infinity, there's the highest denominator power. So we can do some canceling like this, right? But what most professors want you to do is to expand everything out and you get this huge old mess, right? What we can really do is we can cancel the 1 right there, because right now we'll just have 24, okay? So 24, but here's a really cool part. You see we have an n squared here. Those together is an n squared, so they just cancel out. So what you're left with is a 48 over 2. And now over here, you see, you'll have an n squared, and then you have another n in there. So what you have is 24. A mistake that I still make, or I made when I really was trying to learn this, is forgetting about this 2. You have to times whatever is here by 2, just because it's there. And then divided by the 6 here. But you can see how this n and then that n cancel out with that n cubed. Equals 24, 56. So now to check our answer, we got 56 here. What we're gonna do is, we're gonna do it the proper way, or like the easy way. What was my question? Order to $64 subtract 8. And you can see doing it both ways, we got the same answer. And that's how you know we did it right. So the shortcut was, do not expand everything out. You can just look here and look at what everything is. You have an n squared here, you're gonna have an n squared there. That just becomes a 1. So now you just have 48 over 2. Here, n cubed, you have 3n, so you got another n cubed. And then you just can't forget about this 2, and always remember to divide by the 6. If you like the way that I taught this, click the first link in the description.